Alrighty, let's see what we got here. Looks like Trig Lecture 1129, 1130, 21. The student will review, operative word, review solving trigonometric equations for values of theta such that 0 will be less than or equal to theta, which is less than 360 degrees. So we're going to be limiting ourselves to one trip around the axes there, so to speak, one trip around. And we're going to be doing the same thing we've done in the past. Why we're having a review of this, we may never know. We shall see. Reminder, we will use all students take calculus, the unit circle, and special case triangles in our efforts to solve these equations. This is a review. Also remember that if you run into radical 3 over 3 and you're using special case triangles, that's the same thing as 1 over radical 3. If you run into radical 2 over 2, likewise, that's the same thing as 1 over radical 2 if you're using special case triangles, okay, which we will be doing. With this in mind, we're going to solve for theta. We're limiting one trip around the axes. Theta is just one trip around, be between 0 and 360 degrees. So here we go. I'm going to solve this using some algebra. I'm just going to talk my way through it. If there's anything that you don't understand, bring it up in class and I'll try to clarify for you. First thing I'm going to do is subtract 4. Then I'm going to divide by 1/5. So when I subtract 4 from this side, I'm thinking, well, I'm going to subtract 4. That's minus 20 over 5. 20 over 5, 20 divided by 5 is 4. The reason I'm calling it 20 over 5 is so I have a common denominator. 21/5 minus 25 is 1/5. Is equal to, these cancel each other out, 1/5 tangent theta. Now I want to divide both sides by 1/5. Remember that to divide by 1/5, we invert and multiply. Multiply both sides by 5 over 1. On this side we get 5 over 5, which is 1. You can think of it as canceling these out and leaving a 1 over 1. Either way you go, you're going to get 1 is equal to the tangent of theta. This turns into a 1 times tangent theta. And as you recall, I said if you run into a 0 or a 1 or a negative 1, you're going to be dealing with the unit circle, except for tangent. So I'm going to be using a special case triangle, and in this case I happen to remember that it's this special case triangle. Okay. That's theta is actually 45 degrees. It's a special case triangle. And whenever I use special case triangles, I'm going to be looking for a reference angle, and then I'm going to take into account the fact that tangent is positive, and I ask myself in which two quadrants is tangent positive. So here we go. The tangent of 45 degrees is 1 over 1, opposite over adjacent. Therefore, if the tangent is 1, then the reference angle is 45 degrees within the context of what we're doing. Now we're going to find reference angle of 45 degrees between 0 and 360 degrees, where the initial side of our angle of rotation is the positive x-axis. And we're going to stop in the quadrants in which tangent is positive. Tangent is positive. We use all students take calculus to determine which trigonometric functions are positive and where. And so I see that all of them are positive in quadrant 1, so our angle could be a quadrant 1 angle, 45 degrees in quadrant 1. Only the sine is positive here. The sine and its reciprocal, cosecant. Sine is positive here. Tangent is positive here. So since I'm dealing with tangent equaling positive 1, my angle could be here or here. So I'm looking at an angle of 45 degrees as one of my answers. Or my angle could be in quadrant 3, which would be 180 plus 45, which is 225 degrees. So theta if tangent is 1, and I'm limited to 0 is less than or equal to theta, which is less than 360 degrees, then theta could be either a rotation of 45 degrees or theta could be a rotation of 225 degrees. This should ring a bell. We just did it not too long ago, and we're reviewing it for a specific reason, which you will see in the future, not too distant future. I need to find my key and see if I got it right. 45 and 225, is that what I got? Yay! This should ring a bell. We just did something very, very similar to we just did this exact same type of thinking. And we're going to review it for what may or may not be coming. So here we go. Let's take a look at another one. I've got another tangent function, so I'm going to isolate this by subtracting 1 from both sides and then multiplying both sides by 2 over 1. This dividing by 1/2 is to multiply by 2 over 1. So here we go. I'm subtracting 1. I'm using a common denominator here, so I'll think of this left side as this 2 minus radical 3 over 2 minus 2 over 2, and we add our numerators and keep the denominator the same. So this will give me, keeping the denominator the same, 2 minus radical 3 minus 2. We can combine these like terms. 2 minus 2 is 0, minus radical 3 is negative radical 3. This will give me 1/2 tangent theta. I don't want 1/2 tangent theta, so I'm going to divide by 1/2, which is the same thing as multiplying, same thing as multiplying by 2 over 1. In doing that, these will cancel, leave me with negative radical 3 over 1, which is negative radical 3, is equal to the tangent of theta. If I haven't made any mistakes. And now, this radical 3 tells me that I'm going to be looking for a special case triangle that involves a radical 3, and that's this one. 30, whoops, I said 30 and then I wrote 36. 30, 60, right, 1, 2, radical 3, and I'm looking for an angle such that if I take the tangent of it, I get radical 3. This minus sign just tells me which quadrant I'm going to be in, which we'll deal with that here in just a second. So I'm looking at this and I ask myself, which of these angles has a tangent of radical 3 over 1? Don't worry about the minus sign. This tells me which quadrants we're going to be messing with. The tangent of 30 degrees is 1 over radical 3, which is not radical 3. The tangent of 60 degrees, opposite over adjacent, is radical 3. That tells me that my reference angle is radical 3. Is 60 degrees, I'm sorry. And now I just got to determine where is the tangent negative. So I'm looking at this right here. All students take calculus, so to speak. Everything is positive here. I'm looking for where tangent is negative. Tangent cannot be negative in quadrant 1 because all trig functions are positive in quadrant 1. Tangent cannot be positive in quadrant 3 because tangent is positive in quadrant 3. So it can't be quadrant 3. Therefore, my reference angle of 60 degrees is going to be drawn in quadrant 2 and quadrant 4, and will determine the angle of rotation where the x-axis is, the positive x-axis is our initial side. We'll rotate in a positive direction and stop between 0 and 360 degrees. So that's more than one place, possibly. And it will be. If I stop with a reference angle, oops, I went too far, there we go, 60 degrees, that's the angle that's formed between my terminal side and the nearest x-axis. This is 60. That's my reference angle. What I want to know is, what is this rotation if this is 60? Well, the full rotation will be 180, so I'm 60 degrees shy of 180, so one of my angles is 120 degrees if I haven't made a mistake. So I'm going to make a note of that. Theta could equal 120 degrees. If I take the tangent of 120 degrees, I should get negative radical 3. The other quadrant, I'm going to draw a 60-degree reference angle in, would be quadrant 4 because tangent is only positive in 1 and 3, so quadrant 4 reference angle 60 degrees would look something like this. That's not a very good angle, but the reference angle is between the terminal side and the nearest x-axis, and I want now this angle of rotation. So this is 180, 270, if this is 60, this is 30, so that would be 300 degrees. Or you can think of it as 60 degrees shy of a full circle rotation. So 300 degrees any way you go, those would be our two values of theta, such that if I take the tangent of them, either one of these, I'll get a negative radical 3. Negative because I'm in quadrant 2 and quadrant 4, and 120 and 300 because those are the ones that have reference angles of 60 degrees. Hopefully this is ringing a bell. We have done this in the past. Let's see if I got it right. This is time for me to be embarrassed by missing one. Number 2. 120 degrees, 300 degrees. Yay! So there we are. That's what we're looking for. Let's run through a couple more. See what we're dealing with here in our little review. I want to isolate the cosine of theta. So what I'm going to do is add 3 to both sides. When I add 3 to both sides, that will isolate cosine theta. On this side, I'm going to add 3, I'm going to call it something over 2. Well, that would be 6 over 2. I add 3 here, I add 3 here. The reason I'm calling it 6 over 2 is so that I have common denominators. This cancels, gives me cosine theta is equal to negative 6 plus 3. I'm going to add my numerators and leave the denominator the same. So negative 6 plus radical 3 plus 6. 6 and negative 6 cancel each other out, leaving me with radical 3 over 2. It's positive, so that tells me, that'll help me determine which quadrant the reference angle is in. And radical 3 over 2 tells me that I'm going to be using a special case triangle. So here we go. I'm going to draw my special case triangle. 30, 60, right triangle, 1, 2, radical 3. And I've got to remember which quadrants I'm in. All students take calculus. So let's figure out which quadrants we're going to be in. Cosine is positive, so I could be here or here. I can't be here or here. So I'm going to be in quadrant 1 or quadrant 4. Remember the quadrants are 1, 2, 3, 4. And I just got to determine what my reference angle is here. So I'm dealing with cosine, which is defined as adjacent over hypotenuse. So if I go from a 30-degree perspective from this angle right here, radical 3 over 2 is exactly what I'm looking for if I take the cosine of it. So my reference angle is 30 degrees. With that in mind, I'm going to draw a reference angle of 30 degrees in quadrant 1 and in quadrant 4 and determine the angle of rotation with the positive x-axis being the initial side and stopping with a reference angle in these two quadrants, rotating in a positive direction because my instructions tell me that I'm going to be between 0 and 360 degrees. That's positive rotation, not negative. So here we go. I don't know where I am. Here I am. Yay. So I'm in quadrant 1. In quadrant 4, my angle of rotation is going to be 30 degrees in quadrant 1. If I rotate 30 degrees and stop, that's an angle of 30 degrees. So theta could be 30 degrees. Quadrant 1 angle with a reference angle of 30 degrees is 30 degrees. The second angle would be in quadrant 4. It'll be a reference angle of 30 degrees between the terminal side and the nearest x-axis. And our rotation here would be all the way around. We're rotating in a positive direction and stopping right here. Well, I'm stopping 30 degrees shy of 360, so my other angle would be 330 if I do my arithmetic correctly. Those are the two angles we're looking for. And let's see if I got it right. Again, we've done this in the past. We're reviewing with a specific reason in mind. The answer key says 30 and 330 degrees. Yay! We'll do one more example just to get your heads back in the game. By now you probably turned this lecture off because you remember how to do it, but what the heck, what are we going to do here? I'm going to subtract 2 and then divide by -2. So here we go. I'm subtracting 2 from both sides. I'm going to rewrite. 1 minus 2 is -1. Now I'm going to divide both sides by -2. This gives me cosine theta is equal to 1/2. Since this isn't a 0, a 1, or a -1, I know I'm dealing with a special case triangle. And I ask myself, which of the special case triangles, there are 2 of them, 45-45 right and 30-60 right, which one involves a 1 and a 2? And that's the one we've already used in the past, the last couple of problems. Looks like this: 1, 2, radical 3. The smaller of the 2 angles will be 30, the larger of the 2 will be 60, 30-60 right triangle. And I'm looking for the quadrants in which cosine is positive, and we just did that. Everything is positive here. Sine, all students take calculus. So again, we're going to be limited to quadrant 1 where cosine is positive and quadrant 4 where cosine is positive. We won't be in quadrant 2 or 3. That's just a coincidence. That's the same as the one above. And here we go. I'm looking for a reference angle that has a cosine of 1/2. So I look at this. The cosine is adjacent over hypotenuse, so it's not 30 degrees. Cosine of 60 is 1/2, so my reference angle is 60 degrees. We draw a 60-degree reference angle in quadrant 1 with the initial side of our rotation, the positive x-axis. We rotate to 60 degrees. And in quadrant 1, that rotation is simply 60 degrees. So theta, one of our thetas, is 60 degrees. The other one, within one rotation, will have it'll stop in quadrant 4, have a reference angle of 60 degrees. We can get down to this, I guess. Might make it easier to see. And we're going to rotate in this direction, stop 60 degrees shy of a full rotation. That's our reference angle right there. So this rotation would therefore be 300 degrees. So theta could be 60 degrees or 300 degrees. In either event, if we plug in 60 degrees or 300 degrees right here, this equation should be true. And let's see if that's what the answer key gave us. I'll check just a second, and we'll be done with this silly lecture. We'll get into some other things in the next lecture. Let's see if I got it right. 60 and 300, yay! So there we go, a little walk down memory lane. We're doing this for a reason. You know you can do this because you've done it in the past. Hey, I should have used 2 colors. So there we have it, solving trigonometric equations for theta such that 0 is less than or equal to, 0 is less than or equal to theta, which is less than 360 degrees. One trip around. You can do this.